Continuing with section 3.6. So we saw what rational functions look like, or what functions we can designate as rational functions, and which we designate as not rational functions. Now our goal in this section is to be able to sketch the graph of a given what? A given rational function. Okay, because that's the function we are discussing in this section. So without using a calculator, remember. So the rational functions have typically have horizontal asymptotes and vertical asymptotes. Horizontal and vertical asymptotes, but not necessary. Not like every rational function will have a horizontal, or every rational function will have a vertical asymptote. Not necessarily, but they typically have asymptotes. So as we have done before, we will get information of necessary information about the function, put it together, and then use that information to sketch the graph of the function. So what we need from the function, or what we can easily get from the function, is the domain of the function. So the domain of a rational function, remember, is because the rational function looks like px over qx. So the rational function has the domain of all. So the domain of the rational function will be all real numbers, such that, what is the condition? That q of x is not equal to 0. So you can figure out where q of x is 0, and you have to throw those numbers away from the set of real numbers. That gives you the domain of the rational function. Now intercepts. So for any function we are dealing with, if there is an intercept, we can find it. If there is a y-intercept, we should be able to find it. To find the x-intercept, what do we do? Remember, no matter what function it is, whether it's a polynomial, whether it is a rational function, whether it is well, what type of function have we seen? Radical function, whether it's an absolute value function, whether it's a what else? So whether it is a exponential function that we will look at later in next chapter, logarithmic functions, trig function, always to find the x-intercept, you set y is equal to 0 and solve for x. And to find the y-intercept, you set x is equal to 0 and solve for y. So here we said to find x-intercept, set y equal to 0 and solve for x. To find the y-intercept, set x is equal to 0 and solve for y. Third thing that you have to do is find all the vertical asymptotes if there are. So notice here that the rational function can have more than one vertical asymptotes. It may even have 0 asymptote, no vertical asymptote, but it can have one vertical asymptote, or it can have more vertical asymptotes. But there will be only one horizontal asymptote. Okay? So to find the vertical asymptotes, basically we will set our denominator equal to 0 and solve for x. And we will do this assuming there are no common factors like in the top and in the bottom. Okay, that's what we mean. There are no common factors. Remember, when you have an rational number, if you have 27 over for example, 39. So you will be asked to simplify this. So what do? You figure out if there are any common factors. So you should be able to see there is a common factor of 3. So we have to divide the top by 3, or we can write it as 3 times 9 over 3 times 12, 13, sorry, 13. So 3 times 9 and 3 times 13, and now 3 and 3 cancels out, so we are left with 9 over 13. So this is the simplest form of the rational number. In the same way, if there are any factors that can be cancelled out, we will cancel them, and those cancelled factors actually produce holes in your graph. Okay, so we will, if we have time, we will see that type of example, but usually in exams we avoid those type of functions. Only um, we are only going to do functions which do not have any common factors. Okay, so this is how you will find the vertical asymptote. You will set the denominator equal to 0 and solve for the x values, and then throw away those x values, find the domain, but those x values are going to be your vertical asymptotes. Next. Now to find the horizontal asymptote, there is a way to find it very quickly, which is expressed here. You can also plug in numbers and check. Like, so for a horizontal asymptote, remember what we are checking is that if we pick a very large x value or very large positive value for x, what happens to the function value? So where is the function value? Now, since you are not allowed calculator in the exam, I would not suggest that method. Okay, by plugging in large large positive or large negative values and then simplifying your expression and getting an answer, it will take up a lot of time and might not be even possible if you have higher degrees of the polynomials. So there is a neat method here. So in which you basically just compare the degrees of the top and the bottom, and you can tell what will be the horizontal asymptote. And so we are comparing two numbers, which mean the degree of top and the degree of bottom. So remember, the top is P of x, the bottom we are denoting by Q of x. So we can even have so we can even have them written out. So like an b to the, so an times x to the n, and so on. So you can write them as a whole long, but I don't want to get into that confusing notation. So you just keep this in mind, that if the degree of px is less than the degree of q of x, so if the top degree is less than the bottom degree, the HA is the x-axis. So you'll say the HA is y is equal to 0, because y is equal to 0 is the equation of the x-axis. Now, if the degree of the top is the same as the degree of the bottom, then the horizontal axis will be y is equal to lead coefficient of the top divided by lead coefficient of the bottom. I hope everyone knows what lead coefficient is. And third case is that if the degree of top is more than the degree of the bottom, then there will not be a horizontal asymptote. There are usually, in those cases, we have slant asymptotes, but we are not doing those type of problems with slant asymptotes. So we only focus on the vertical and horizontal asymptotes. Okay, so basically we have found a lot of stuff, and we could start graphing our function at this stage, but it will be wise to check some more things. There is one thing which is sign chart, and the other is the question, will the graph cross its horizontal asymptote? Because in rational function, there is a myth, I would say, that function never crosses the horizontal asymptote. Yes, it never crosses the horizontal asymptote when it's far away over here. If this is the HA, so the y is equal to b, let's say this is your HA. So the function will not cross the horizontal asymptote when you are far away to the right or far away to the left. But in between here, in the middle, it might cross. So will it cross or will it not cross? We can easily check. What we do, we set our function to be equal to, or the y value we set it of the function, we set it equal to the value or the number which we have in the horizontal asymptote, and then we solve for x. So if there is a solution, you'll get the x value where the graph will cross the horizontal asymptote, and if there's no solution, it means it does not cross the horizontal asymptote. And the last thing is the sign chart. Why do we need the sign chart? Well, in this case especially, it's very important to have the sign chart, because when you will have the vertical axes, so let's say this is a vertical axis, and then let's say there is another one over here. So we could even have another one, but let's focus on these two. So you want to know whether my graph will be hugging this asymptote from this side, or will it be hugging it from that side, like this, okay? Or will we have a, so this and this situation, or you know, or will we have this and this situation? It will hug from here, and on the right it will hug from the top, or both will hug both sides. From both sides it will be hugged down while looking down. So that's why we need the sign chart. Okay? Will it hug like this? That's and the same thing with the other vertical asymptote. So that's why we need the sign chart. Okay, so let's look at an example now, actually. So I'll do this example in this video, and then maybe the next example. There are, I think, 3 more. So I might make one video or make separate videos for those. So we start out, by the way, this is interesting. This is a linear function divided by a linear function. When you have this situation, you can actually convert it into a transform of the function 1 over x. So remember, our function 1 over x looks like this. If you have 1 over x minus 2, what does that mean? It means you shift the function, this function, 2 units to the right. And if you have 1 over x plus 3, means you shift your 1 over x 3 units to the left. And if you have 1 over x plus 2, means you shift 2 units up. And if you have 1 over x minus 2, you shift 2 units down. So this type of function, when you have a linear over a linear, you can easily get it into, find into a transform of the 1 over x. So how? Do the long division. So do the long division. So negative 3x plus 1. That's what we have here. And we are going to divide it by 2x plus 3. So I have a negative 3x, and I am going to divide it by 2x. So what do I get? Negative 3 halves. So I will put the negative 3 halves up here. Actually, okay, negative 3 halves. And then I multiply, so I get negative 3x minus 9/2. So this cancels, and now we are left with 1 plus 9/2, which becomes 11/2. So you can write your this function as negative 3/2 plus 11/2 divided by 2x plus 3. So I can write this as 3/2 negative 3/2 plus 11/2 divided by negative 2x plus 3. So we can rewrite it now, negative 3/2 plus. So this is what I am going to do. I can put the 11/2 here, and then we are getting 1/2x plus 3. Okay. We'll factor out the 2 from the bottom. Okay, so we combine the 2 here with the 11/2. So we get negative 3/2 plus 11/4 into 1/x minus 3. So you see the translated or transformation of 1/x here, and this is just like a scale which means it's stretched vertically or compressed vertically. Okay, but if this is more work, maybe let's try to see if we apply our information that we have learned. So first thing, we look at domain. So the domain will be, you can see x cannot be negative 3/2. So we will say domain is equal to negative infinity to negative 3/2 union negative 3/2 to infinity. Well, range is something that we cannot say right now, but after we graph the function, then we can talk about the range. The next is maybe the x-intercept. For the x-intercept, we set y is equal to 0. So now remember this, that when you set a fraction equal to 0, basically it means the numerator is equal to 0. So I can go from here and say that 1 minus 3x is equal to 0. So which gives me x is equal to 1/3. So that is my y-intercept, x-intercept. What about y-intercept? So for y-intercept, we set x is equal to 0. So when I do that, y will be equal to, so x is equal to 0 implies y equals 1/3. By chance, we are getting both have the same value, but of course they are on the different axes. What was the next? Next was the VAs. So the VA you get by setting this is equal to 0, which is the same thing as the number that we threw away from the domain. So we get x is equal to negative 3/2 is our VA. What about HA? So if notice that the degree of the numerator and denominator both are same, so the lead coefficient, the HA will be y is equal to the lead coefficient of the top, which is negative 3, divided by lead coefficient of the bottom, which is 2. Okay, so next thing we check is, will the graph cross the axis or not? So the horizontal axis or not. So we set the y value equal to, so we'll take our function basically, the y function value or function, and set it equal to the horizontal asymptote, which is -3/2, and try to see if we get a solution. So in this case, you can do the cross multiplication, and we end up getting 2 times 1 minus 3x equals -3 times 2x plus 3. So when I try to solve it, and I get 2 minus 6x equals minus 6x minus 9. So minus 6, we add 6x on both sides, so we end up getting 2 is equal to -9. So this is not true, so no solution. So it means graph does not cross the HA. So does not cross the HA. Okay, and now we try to graph it on the right. So I have the VA is -3/2, and the HA is -3/2 as well. Yeah. So this is -1, 1, -2, and -3, and over here 1, 2, 3, and then so first thing you should do is draw your the asymptotes. So the vertical asymptote, remember, is y is equal to -3/2. So x is equal to -3/2. So we have a vertical asymptote here, and then we have a horizontal asymptote over here. So now basically we have to can draw the function, but now we need to know where will it be. Now also notice that x is equal to 1/3, so which means somewhere here the graph will cross the x-axis, and over here it will cross the x-axis, which should give you an idea how the graph will be. But just to make sure that we are doing it correctly, we can make a sign chart. Actually, even if the question doesn't say, you should make the sign chart. Okay, so what are the numbers that go on the number line? Let me use a different color so that you doesn't get confused. So we are doing the sign chart here. So we have numbers. The zeros, the 0 was 1/3, and remember we are looking at x values, and the missing number was -3/2. The vertical asymptote that will come on the left, and then on the right we have the 1/3, and that's all. We have just two numbers. So we pick a value on the left side, for example -2, and I can pick 0 here, and I can pick a 1 over here. So when I have -2, think of plugging in the function -2. So -2 will make this quantity positive. So you get 1 plus 6, and the bottom will become negative. So you have a negative value. So here the function is below the x-axis. Then between -3/2 and 1/3, so plug in 0, you see you get a positive value. Then if you plug in 1, you get a negative value. But again, this is not enough. Why? Because when we say that on the left of negative 3/2 means on the left of this asymptote, it is going to be below the x-axis. Well, this portion is below the x-axis, and this portion is below the x-axis. So how would it be? How would it be? Will it be coming like what? Well, we have our horizontal asymptote over here. So the function, and we just found the graph doesn't cross the horizontal axis in this case. So you cannot be coming like this, or you cannot be, coming from up here like that. So how will it be? And for that, now if we can figure out some values, get some values of at least one value, so that will tell you whether the graph is going to be here or here in this compartment or in that compartment. So for example, pick the value -3 and plug in your function. So when you plug in your function -3, you get 1 plus 9 over -6 plus 3. So we end up getting 10 over -3. That is about -3.33. So which means the value is somewhere here, which is telling you the graph of the function will be in this region. So it will go like this, because it has to hug the vertical asymptote and it has to hug the horizontal asymptote. So now there can be no piece up here, okay? Because if I make a piece up here, then that is not a function, because vertical line test fails. So where did we go now? Okay, so now looking on the right of the vertical asymptote -3/2, what will I do? I again check values. So when we are at -1, where the graph will it be up here or will it be down? So basically positive or negative will. So plugging in -1, right? Plugging in -1 will give you, so -1 will give you 1 minus -3, so 1 plus 3 divided by -2 plus 3, so which is 4 over 1, which is 4. So it means at -1 the value is 4 here, so it means we are going to come like this. And then remember, we have to get to this number and then we have to get to that number. Now here the function is going to go down, but because this is a horizontal asymptote, so eventually it is going to get level with the horizontal asymptote. It will not cross the horizontal asymptote. And this is the graph. But you see now how compact all this information I have put together. That's why I say use a separate paper to graph the function so that things look more clear. So, okay, we will do the next example in the next video.